Okay, so hi all, welcome to this webinar on data science. Today is a demo session for a training on data science and machine learning with Python. So before we go ahead, this is our course page, Machine Learning with Python. So you can come here anytime and all the course content is available here. Okay, so let's start from the beginning. Day zero. So why machine learning? So today, basically what we are trying to do is understand why do machine learning or why learn machine learning. So essentially what we are going to cover is what is machine learning. We'll take some examples. That's what we'll cover here. Okay. Next, we'll talk about R versus Python, meaning there are a couple of languages that you can use to do machine learning and data science. We'll understand which language is better. We'll do a couple of demos, small demos, so that you won't be overwhelmed. At the same time, we'll understand the crux of machine learning just with these small demos. And then we'll talk about traditional programming versus machine learning, meaning, for example, if you are a Java programmer or a C language programmer or a web developer like HTML, that's all traditional programming. So we'll understand how traditional programming is different from machine learning. And then we'll also cover the path that you need to take to completely undergo this training, machine learning. And then we'll cover a couple of frequently asked questions, and we'll open up the session for any questions that you have. All right, so in the meanwhile, if you have any questions, just raise your hand. I can unmute you, and then you can ask question anytime you want. All right, so let's start with the basics, okay? So what is this whole buzz about data science? Why do you see so many things floating around on data science or machine learning? These are all different terms. Machine learning, data science, data analyst, or deep learning. These are all different terms for the same thing, dealing with data. So I want to give you some examples before we try and understand the course structure, etc. So let's look at some examples in the real world, okay? But before we do that, let's say if you look at this, if we have watched this movie, The Avengers, there are so many Avengers, right? Iron Man, there is Hulk, there is Black Widow. Who is your favorite Avenger? Most of you, according to surveys, most of us have said that Iron Man is our favorite Avenger. Now, why is that? Why is Iron Man our favorite Avenger? The reason could be very different because you see, all of them have superpowers, right? Captain America has some kind of a superpower. He's very strong. Hulk has a superpower. Thor has a superpower. But this is the only guy who does not have any superpower. But still, according to many surveys and polls, he is the most favorite Avenger. The reason is simple. Of course, he's human. He doesn't have any power. We try to empathize with him. On a lighter note, he has something that none of the other Avengers has. What is that? It's Jarvis, right? If you have seen the movies, you know that what powers Iron Man, other than his suit, of course, is Jarvis, his digital assistant, right? Without Jarvis, there's no Iron Man, isn't it? That's the reason why he's so popular, because he has AI behind it. Jarvis is essentially an AI assistant, artificial intelligence assistant, right? Now, that was on a lighter note, but let's look at some real examples. Anytime you have browsed Amazon, you see a lot of product recommendations, right? So what is a product recommendation? You buy something and then something else shows up. You have seen this 1,000 times. Same thing with Netflix movie recommendations. So there is Netflix, and on Netflix, when you watch a movie or when you watch a serial, something else shows up as a recommendation saying, hey, you know what? You like some movie, you might also like this movie, right? These two are actually examples of what is called as a product recommendation engine, or it's also called market basket analysis. This was invented much long ago, probably 20 years ago. This is not new. Amazon and Netflix have just implemented it in their system on a much massive scale with so much of data that you tend to see those results very effectively. Okay, next we have Google ad targets. So what do I mean by that? So let's say you're browsing something, right? You're browsing a website, and then you have certain keywords that you have used to reach that website, right? If you are in India, probably you'll be using Times of India or any of those news websites. And based on your keywords and based off of what's there in that website, Google will essentially target those ads, right? You can just see it right here. You just type in Times of India, right? This is today's news. And you can see that there should be some ads here somewhere. See, 3 months Swiggy super membership at ₹1. So why is that being shown? Because Google in this browser, on this browser, has stored my preferences. So I use Swiggy a lot. So it is boosting that particular ad so that, you know, it makes sense to me. That's called as targeting an ad, right? How is it done? Using data science, and of course using a bunch of machine learning techniques. Then chatbots. What is a chatbot? Now, these days, if you go to ICICI.com or any banking website, typically, you'll see that there is a chatbot, right? And that chatbot will be able to guide you with certain things. It's not a fully mature technology yet, but it will be pretty soon, believe me. And then, of course, the more famous self-driving Tesla cars. These days, the Tesla car in the United States need not be driven by hand, by a human. A human can just actually sleep in his car, punch in the destination, and he can be right there, right? Face detection. You take a selfie of your group, post it on Facebook, all the faces are identified and tagged accordingly so that people know that who or what their friends are doing, where they have been at. There is geotagging, there is face detection. And the list goes on and on and on. These are all examples of systems that have already been implemented and are extremely effective. These are not some fantasy things, right? You know it because you have seen them in the news already, or you have experienced them like Amazon or Netflix. Now, these are all examples that we see in the consumer world, meaning business to consumer world, like retail or cars or supermarkets or banks. But there is a lot of machine learning that goes on behind the scenes. One example is PayPal's fraud detection. In fact, fraud detection is common not just in PayPal, but in many, many, many different companies that do finance. For example, any credit card company, you take anything, ICICI, American Express, any credit card company, they have to have a fraud detection engine. Meaning, say if you lost your credit card, or somebody has stolen your credit card, and somebody is using it somewhere in Punjab or Kerala or some location that you are not in. And this happens suddenly. You could travel to Punjab, right? You could travel to Kerala on a vacation and still use your credit card, which is a valid scenario. But there are some situations where it's not a valid scenario. And that's when machine learning comes into the picture. Based on certain signals, it can identify certain false data, fraudulent data, and it can immediately trigger an alarm, maybe send an SMS to you, block the transaction, many things could happen. And then cancer detection based on MRI scans. So most of you might not have been to an MRI system, but what is an MRI? An MRI is some kind of a machine where you go in and then your brain is scanned, your body is scanned. Based on that, it's not easy for a radiologist to identify some maladies like cancer or anything. But if you train a machine well enough, it can easily detect some of the patterns that might be difficult for a radiologist to perceive, right? Now, these are all okay. So we have just seen some examples, right? Now, what is in it for you? Okay, what role can you play? We think that these things don't touch us, but when you go out as a software engineer or a machine learning engineer, work in these companies, these are all examples that you need to be familiar with, because not just because these examples are important, but we need to understand what is happening behind the scenes. Let's look at one practical example of machine learning right on the face of it. Okay, now you can just go here, click on these URLs. This is an example of machine learning that when you give it a picture, it will make it into an art. Okay, so this is an art that a computer has done based off of this machine. Point being, the way ML and machine learning, when I say ML, I mean machine learning. The way data science and machine learning is progressing, it's invading every field. It's there everywhere, not just in banks, not just in Facebook. It's there doing paintings. It's there also doing music. You can just click this link and you'll see some examples of music being synthesized by a machine learning algorithm. In fact, it's called a deep learning, but we'll get to that. All right. So, like I said, we need to be aware of machine learning as a consumer, as a programmer as well. Now, let me give you one simple example. So if you go to this Google Vision API, you can go click on that link whenever you're free. You click on that link and then you can upload a picture. In this case, what I've done is I've taken this picture off of Wikipedia. It's just a flower farm with a windmill and some buildings, right? You upload it to this API, right? Google Vision API. And here is what it gives you. You see, there is flowers with 97% probability, right? When we talk about machine learning, most of the time it's probability. But don't worry about it. We'll talk about probability in the course quite a lot. And then there is windmills, there is flowering plant, there's field, and all of this has happened automatically. It's so seamless. There was no human behind the scenes. Just like face detection happened in Facebook, right? Now, say you're not a student, say you're not a programmer, say you're a domain expert. For example, I talked about that MRI system, right? So say you're a radiologist, meaning you go to you have some bone you fracture, let's say. You you go take an X-ray, right? Similar to that, there is an ultrasound. There are many different diagnostic things like that. And a radiologist is the one who is an expert in identifying where is your liver, where is your kidneys, where is your pancreas, where is your stomach, where is all these things. But what about him? What role does he have? Does he have a role? Yes, he has a role. He is a domain expert. A machine learning algorithm is only as good as its trainer. So domain experts are also needed in data science. Without them, there is no data science. Because who is going to teach data science or data patterns to the system or the algorithm? The algorithm basically learns. That's what I intend to say. Okay, now in terms of job opportunities, data science has been dubbed the sexiest job of the 21st century. And why is that? It's because there are so many jobs and this was done by none other than the chief data scientist. This whole thing, this whole statement was given by him. And it was never a case that there was a chief data scientist. There was a chief radiologist, there was a chief that, and there was a chief this in the United States. But there was never a chief data scientist. And in fact, it was an Indian who was the chief data scientist. And if you go to any job portal, you'll see a whole host of job openings for freshers, for experienced folks. There are all different kinds of job openings. Okay, now let's go back and look at R versus Python. No, what is R? What is Python? Most of you might know Python already because it's so popular. But R, the letter R, is also another popular programming language. And it's specifically designed by statisticians for dealing with statistics. Now I'm using a new word here, statistics. Why am I using the word statistics? We are trying to learn data science and machine learning, right? Why do we need to talk about statistics? Because underlying every data science or machine learning algorithm, there is statistics. So mathematics and statistics are the core of the machine learning algorithms. Now, you don't have to be an expert in it. We learn enough statistics, enough math, so that we can complete the course and we can have a good understanding of machine learning. But we don't have to be an expert in statistics. I just want to throw that point out there. So when we choose this language, okay, when we choose this language, one second, I'm just are you able to hear me? Is everybody able to hear me? Hello? Okay, all right. Okay, so the next question, when we choose the language, probably the first question, apart from R or Python, is, do I need to be a programmer? because programming sometimes scares people, and that's understandable. But if somebody says you don't need programming, then they're lying. The short answer is yes, you need to be a programmer of some sort. You don't need to be a first-rate programmer. It's not like learning Java programming or not like HTML programming. There is a whole bunch of you. There's a whole bunch of coding that is required. But in data science, there is a funny thing that goes on, because data science or machine learning these are not programming heavy. These are not programming heavy. Okay, these are not programming heavy. These are concept heavy. So you don't have to worry about programming. Can I be a programmer? Can I do this programming? No, that's not a big deal, because even if you know some basic programming, that's good enough. But what you have to be a good machine learning or data scientist is be able to understand and grab concepts well. Okay, so to understand the question simply, do I need to be a programmer? Yes, you need to be a programmer of some sort, but programming is not such a big deal in data science. Just because you don't know just because you're not good at programming doesn't mean that you'll not be good at data science. But if you don't understand the concepts well, I said concepts, nothing to do with programming. If you don't understand the concepts well, then you'll not be able to do a machine learning job or be a data scientist. Okay, so when you compare Python with R, so the next thing is, which language should I learn? We know for sure that we have to learn a language. So which language should we learn? Python, R, these are the two choices. I strongly recommend Python if you are a beginner. Now, there are some experienced folks who come from statistics backgrounds or other kinds of backgrounds. They can choose R, not a problem. But beginners, I strongly recommend that you choose Python. Okay, the reason is all new development, especially in the field of deep learning. We're going to talk about that when we discuss the FAQs. When we come to deep learning, Python is the preferred choice because all development is actually happening in Python. You can still do things in R. Deep learning can also be done in R, but the actual algorithm is in Python. R is just calling those algorithms. So R is like a shell when it comes to deep learning. But for machine learning, general machine learning, both are equally okay. Okay, but if you're a beginner, I strongly recommend that you do Python because it's easy and it's very predictable. If you know the C language, Python is no big deal. Okay. All right. Next, let's move on to a machine learning demo. Okay. We have seen Google Vision, right? The first thing that we have seen is Google Vision, where we show an image and then Google already identifies the data. Next, I want to show you another example, Google Quick Draw. Okay, so you can play this game when you have some time. Just type in Google Quick Draw, and then the challenge is, see, draw a beard in under 20 seconds. Okay, now I draw a beard something like this, right? It's actually trying to predict that it's a beard or not. I'm actually not able to draw it properly, but if you have some nicer mouse, you'll be able to draw that beard. Draw a wristwatch, okay? I'm trying to draw a wristwatch here, see? Oops. Okay, something like this. And then, oops, I couldn't draw it. Draw a computer, right? Okay, draw a soccer ball, which is a football, right? Yes, it has identified. So basically you get the point, right? So that's quick draw. How is it trying to identify that I'm trying to draw a soccer ball? Completely using AI. And if you actually do a couple of those pictures, it will show you all the pictures that somebody else has drawn. Meaning people like me, they have drawn pictures and then they have trained the system. Point being, I'm reinforcing the same thing again. A learning algorithm doesn't learn in space. It learns from our data. We need to train it. Okay, and that's what has happened with the vision, with the quick draw, or any of the examples that you see in machine learning. Next, we're going to see a more concrete example. Okay, something that we can do using the program right now with just probably how many lines of code here? 55 lines of code. Okay, don't worry, I'm not going to actually ask you to write this code or run this code. There is a point I want to make. But before I do that, let me give you an understanding of what we are trying to do here. This is an example of an actual data set that we'll be doing sometime down the line, probably in the first 5 days. Okay, so what do we have to do here? Housing price prediction. Okay, so there is a data set called Boston housing. Every machine learning engineer will start here in one of the techniques. Okay, now a government agency has collected some data like number of rooms, pollution in that area, traffic, crime, so many different parameters. And then they said, this is the price of the house. Okay, like so. See, finally, there is a price of the house. For example, 24. This data is way back, somewhere in probably in 1980s or 90s maybe, right? We can get all that information. So $24,000. This is 24K. Okay, this was way back. And for each house, they have said this is the crime rate, this is the zone, whether it's industrial area or not. This is a nitric oxide, meaning pollution. This is the number of rooms. Okay, this because you see the 0.5 because they are averaged. Okay, this is the radius to the nearest commercial center. This is the tax rate. There's so many different parameters. Now the challenge is, if my crime is 0.69%, right, and the number of rooms is 7, can you predict the price of the house? That is the challenge. We have some data. There is so much of data. This is just 6 rows. There is actually, I think, 500 rows, probably somewhere around that. I don't know. Remember the points, or maybe more than that. So this is the data. So given 500 rows of data of different attributes of a house, basically, so there is a house, right? We want to predict the price of the house. Based on what? Based on number of rooms and the pollution. Each thing is quantified. See, I'm not saying it's a high pollution area or a low pollution area. I'm saying this is the pollution, nitric oxide, 0.458. I'm quantifying everything. Everything is a number. All of them are numbers. We'll see when we look at the algorithms that unless there are numbers, machine learning doesn't understand things. Okay, so we'll see those examples. This is lower strata population percentage, meaning poor people, right? So let's say the room number of rooms is 5, the pollution is 0.45, and the lower strata population is, let's say, 5%. Now, what is the price? For us as humans to predict, as you and me are laymen, probably we are not in the real estate market, right? So for you and me, it's difficult. It's not that easy. But for an experienced real estate consultant, that is probably easy because he knows the average parameters. But for a machine learning to predict the price of a house based on these parameters, you see, it's just 50 lines of code. That's it. In fact, this is all not even code for predicting. The only lines of code for predicting is this one line. Don't worry, I'm not asking you to understand what that line says. The point I'm trying to make is such a complicated problem, even for us humans, right? If we are given the data, we'll not be able to predict the price of the house. It's not easy. Maybe an expert can to some degree. But this machine learning algorithm, with just one line of code, rest is all loading the data, showing some graphs and all that stuff. But this is the line of code that's actually trying to do the prediction. Just one line. If I were asking you to write a program, let's say you are an expert programmer, okay? I were asking you to write a program to predict the price of a house. With this kind of data, will you be able to write a program? No. That's another point I want to try to make. You cannot write a program for cases that machine learning is trying to solve. So we have seen so many examples, right? Face recognition, automatic driving, so many different things. Using traditional programming will not be able to solve any of that problems. Now, we are going to talk about that in the next slide. On top of that, I just want to give you an example of a complicated problem that's solved using just one line of machine learning code in Python. Okay, don't worry about what's happening here. You know, what this graph means. For example, in this case, what you see here is a plot or a graph of the price of a house on the y-axis. This is the y-axis, right? On the x-axis, you have the number of rooms. Now, if you look at a pattern, there's not a concrete pattern, but there is a broad pattern. What is that pattern? Well, as the number of rooms increase, it looks like, you know, the price is increasing. That's one conclusion that you can draw, right? Now, how much should it increase by? What should be this angle of increase? Is something that the previous line, this little line over here, has done for us. Right? It has done the prediction for us using some kind of a mathematical algorithm. Okay, don't worry, you're not supposed to understand this at this point. I'm just trying to give you an example of how it would be for you to solve a problem, a machine learning problem. All right. Okay, that should be enough. Okay, now let's talk about traditional programming versus machine learning programming. If you come from some kind of a traditional programming background, like Java, PHP, HTML, JavaScript, any programming is okay. Web programming, Python, any program, even Python. This is the general model of a conventional program. So let's take a web example, right? There's a Java program running on the server and it's showing you some web page. So where is the data coming from? The data is coming from the database. And the program, the Java program, let's say, has all the logic. Now the database, the program looks at the database, takes the logic, and then renders it out as an output onto your browser. So this is how a traditional programming works. Data is fed into the logic, and that gives you an output. Machine learning, on the other hand, let me put both these slides together. Machine learning, on the other hand, the programming paradigm or the way programming happens is entirely different. You see, I'm sorry. The program or the algorithm takes in the data, right? And then outputs a logic. And this logic is determined by the program or the algorithm. You don't have to write the logic. That's the beauty of a machine learning program. When you write a web program, you write the logic. Okay, get the customer number from here. Get if you look at a news website, let's say Times of India, it will say, okay, get the latest news from this database, get the ads from this database, get the movie pictures from this database, so on and so forth. All that logic is here. We write that logic. But in a machine learning algorithm, it doesn't work that way. The algorithm produces the logic. All we have to do is write a program that can implement that algorithm. Now, after the logic is there, we just give it more data for us to give the result. Okay, now, once we do some examples, probably sometime next week, you'll understand what I mean by the difference between the traditional programming and machine learning programming. Right now, it might look a bit weird, but as you start developing programs in machine learning, you'll understand what I mean by this. Okay. I just want to give you one more example. The example I wanted to give was, say, you're asked to write a program, okay? Any program, any language, any program. You're asked to say, there is a number, okay? There is a number, like 2, okay? And then you have to square it, like 2 squared, and the result is 4, okay? This is what you have to do. Given a number, give me the square of that number. So if we give the program 10, it has to do 10 squared, that is 100. For somebody familiar with programming in any language, this is probably a one-liner, right? But probably in machine learning, this will take 5 or 6 lines. Now it looks like traditional programming is so smart. So this is traditional programming. This is machine learning programming. But how did you arrive at this result? So for example, if we were to write it in C or Python, we would say, first get the number. Second, print whatever x equal to that number, print x square. Simple enough, right? So this is the actual logic. Squaring of the number is a mathematical logic that can be easily fulfilled using any programming language's star function. So each programming language has its own way of doing squaring. But in ML, there is no such logic. There is no X, you can do it, but that's not machine learning. Okay? The way machine learning solves is, it tries to understand the pattern. Let me give you an example. So this is X, this is Y. X is some number 2. Y is 2 square 4. So we give machine learning a set of data. So this machine learning algorithm learns from this data. What does it learn? It learns the underlying pattern. The underlying pattern is that this number is being squared. Now, when we have done squaring, it's easy because we know squaring is easily implemented in programming, right? But when we have seen the housing example, see, this is the number of rooms, this is the price, and we've seen the data something like this. So for each room, for example, there is 1 room, 2 rooms, 3 rooms, 4 rooms, 5 rooms, 6 rooms. So for 3 rooms, this is the price. For 4 rooms, this is the price. What is the correlation? Is there a clear example, or is there a clear way that mathematically we can identify that this is the relationship? No, it's really hazy, right? Some numbers are all over, some numbers are here. For the same number of rooms, four rooms, there is one price here, one price here, one price here, one price here. So how does the system identify what is the correct price? With a problem like this, the traditional model basically fails. It doesn't work. Basically, you cannot identify the most optimum price for a certain set of rooms. It's not possible. That is when ML shines. Probably in traditional programming, you'll do a whole bunch of adjustments and arrive at a formula. It will take 1,000 lines or 2,000 lines. You'll do a whole bunch of if, this, else, this, do this. So many different lines. But with machine learning, the same 5 or 6 lines can solve a complicated problem like this. That is the beauty of machine learning. Machine learning is all about using algorithms to identify patterns in data. That is machine learning. That is data science. If you come to the core of it, machine learning or data science is the use of algorithms to identify patterns in data. That's it. There are so many definitions that we are going to see. What is machine learning? What is data science? What is deep learning? In fact, we're going to see that in one of the slides. But if there is one takeaway for you, I know it's a long session. So if there is one takeaway, if you want to remember just one line from this whole webinar, okay? Just understand this. Machine learning or deep learning is the use of algorithms to identify patterns in the data. And this is one example of patterns. Remember this example, the housing data. Okay? Okay, let's move on to the machine learning path. I think we are pretty much done. So what are we going to do in the next couple of weeks? Okay, we're going to start off with Python. So this is the first thing that we are going to do, Python and machine learning. Okay, first things first. Depending on where you are, this will take some time. Sometimes for some people it's fast, for some people it's slow. Okay, so we have to be patient here. Python data structures will take roughly a week. Okay, if everybody is an expert in this, we can just skip this. And this is probably something that most of us will not be familiar with as beginners. So we are going to start with NumPy. It's a package in Python. It's essential for machine learning. And then pandas, and then matplotlib. So this is to deal with numbers. Okay, so this is to deal with data as a frame. Frame means like this, like an Excel sheet. Okay, this is for data visualization. Okay, so this is the technical part in Python. So think of this as all Python. Okay, these are all packages in Python. Now these areas, probability, statistics, linear algebra, this is all math. So we have to understand concepts. It's not programming, it's just concepts. And once we are, this probably will take another week or week and a half. Let's just quickly go here. I'll show you the curriculum so that you understand where we will begin. Okay, so this is where we start. NumPy. Okay, first we look at NumPy, then we look at pandas. Each of it will take a day, not more than that. Okay, and then we look at matplotlib visualization. Okay, and on the next week we'll start with linear algebra, probability and statistics, and then math will be, linear algebra will also be covered as part of any kind of math, right? Probability, statistics, everything will be covered in 2 or 3 days. Sometimes it may be delayed, so let's take 3 days, okay? And then we start with the actual algorithms on day 8. Now, the way these days are designed, right? Day 1, day 2, day 3, these are designed for a person who has some understanding of Python already, okay? And then we start with day 1. Now, if we are not conversant with Python, then what we do is there is another course that will just cover Python. Okay, we start with the Python setup, then we look at the basics of Python, loops, strings, data structures, object-oriented Python, so on and so forth. This will take a week. I've spread it out into 8 or 9 days. But if you compress it, because day 7, day 8 are really not that difficult. We can compress it to 1 week. So if you want to start all the way from the beginning, which most of the students are, because they don't know Python also, they might have some understanding of Java or HTML. But if you start from the beginning, we look at Python all the days, 5 days, just 1 week for Python. And then, so this is all 1 week. And this is probably 3 days. This is another 2 days or 3 days, depending on our speed. And then we start with all the different machine learning algorithms. So this will take somewhere close to 20 days. Okay, there are like 10 to 15 odd algorithms that we'll cover. And each algorithm we'll cover in detail. Let me give you one example. Okay, say we talk about regression. Okay, this simplest algorithm. And we'll cover that algorithm very much in detail, like, why we are doing regression. We'll take some sample data sets, solve that sample data set in Python. Okay, and then we'll understand what regression really means. Okay, and we'll have to go deep into it. There is no superficial way of learning these algorithms. We have to understand these algorithms from the ground up, because they, for example, this algorithm is really the basis for many of the data analytics problems that we solve in a real project. Once we understand regression, actually 50% of the problem, 50% of the industrial problems can be solved, at least analytics problems, with regression. So even though it's a small topic in the grand scheme of things in terms of algorithms, it's a very important topic. So we really make sure that we understand each of these algorithms. Okay, and we'll cover everything that is necessary. Okay, so that is the course structure, the high level structure. I'm not going into the details. It's a very high level structure, just so that you understand the learning path, what you'll be learning in the course. Okay. Then finally, there are some, okay, this is not required. There are some FAQs that I would like to cover. Like, what is the difference between data analytics, data science, machine learning, deep learning, AI? What is the difference between all of these? For example, let's take a problem. We have seen that problem, right? Boston housing problem. There was some data given to you, number of rooms and the price of the house. So there were some data points. And you were asked to predict the price of a house based on the number of rooms. So this is data, and there is some pattern in it. You are asked to identify that pattern, right? So basically what you're trying to do is trying to essentially gather some intelligence out of data. So whenever you are trying to gather intelligence out of data, it's called data science, the science of data. See, you're not playing with anything here other than data. There is a program, there is data, you play with data. So the science of extracting intelligence from data is called data science. It's a very broad term. Okay, this is data science. Now there is machine learning. What is machine learning? Machine learning is typically a field where again algorithms are used, but it is more to do with prediction. You see, this is machine learning, and it's more to do with predictions. What do I mean by that? Now we have got a pattern. Okay, now what if we increase the number of rooms? Say for example, somebody is trying to build some building community, is trying to build a huge villa with 12 rooms. Okay, it's uncommon, it's not natural. There are no villas with 12 rooms, let's say, even for America. Now, what would be the price? Can you identify the price? Yes, we can identify the price. So this is called prediction. So generally, when you try to predict the future by understanding the patterns of the existing or past historical data, that's called machine learning. Predicting unseen or future data based on historical data. You could use a normal machine learning algorithms. You could use anything you want. As long as you're predicting unseen or future data based on historic data, it's called a machine learning. Now there is something called as deep learning. In fact, when you see a self-driving car like Tesla or image recognition using Google, it's called deep learning. Okay, let me erase this. This is data science, right? This is ML, and then DL or deep learning is a sub part of ML. DL uses or deep learning is a part of ML, but it uses a special technology called neural networks. So when you're trying to solve a machine learning problem using neural networks, we call that as deep learning. That's it. Just a specific use of a technology. Okay. Now, what is artificial intelligence? That's another word. Artificial intelligence is typically making a machine seem intelligent. For example, the auto-driving Tesla car is a machine behind the scenes that's seemingly intelligent like a human, right? A human can drive, machine can also drive. So it's essentially making a machine seeming intelligent using a combination of data science, machine learning, and deep learning. You can use any combination you want, and that's a general term for AI. Now, if you look at the pattern here, this is deep learning, okay, a specific technology, and this is machine learning using some algorithms, and data science, and this is data science. So there is a lot of interchange here, meaning there's a lot of overlap. AI is overlapping with data science, and I've left this out because there is some analytics, business analytics. For example, a company is trying to do some analysis on their data, like how much sales has happened. What is the difference between the sales between previous year and current year? That's all called analytics. So there is no artificial intelligence there. It's just trying to compare yesterday's data with today's data. So that comes under analytics, business analytics. And it's a very important field. For example, tools like Tableau, right? Or Power BI, Microsoft Power BI. These are all examples of business analytics tools. The difference is that these are not predictive in nature. These are not predictive in nature. Okay. However, AI need not be just predictive. Okay. But as long as it makes things seem intelligent, it's an intelligent system. For example, there are certain rules-based engines. There is no actual predictive power in it, but still you can classify it as artificial intelligence. Okay, so these are actually being phased out. There are no rules-based engines these days, but there used to be. And there are some also, you know, it's not wrong to have rules-based. There are some situations where you can use rules-based engine. They'll be perfectly valid as AI. And this is the sweet spot that we will be focusing on. Okay, a bit on this part, analytics, general analytics, and a bit on this part, which is some kind of a predictive analysis using a combination of machine learning algorithms and deep learning algorithms. So we as in this course will be focusing mostly on the part that this thing is enclosing, right? So we'll be covering on the data science part here, ML and deep learning. All right. Okay. Then what is the duration of the course? The duration of the course is typically, depends on how well we cope up. So most of the time, typically this is somewhere around, this is somewhere around, 45 days. If we exclude Python, for example, it will be reduced. So 45 days, including weekends and everything. We're not going to do it on weekends, but 45 because you need a lot of time to exercise and practice. Okay, so it's 45 days total. Just the course. I'm not talking about projects. I'm not talking about any of that stuff. Just the course. So Next thing is, I'm not good at programming. Can I become a data scientist? We have covered that in detail. Yes, you can be, but you need to have some level of programming. You don't need to be an expert. Next is, what is the current job situation for data science? How is data science job market? Data science for job market is pretty hard. At least it's going to stay there for some time now. I'm not saying there are billions and zillions of jobs, but there is a pretty decent number of jobs in the market, because there are so many data science based products coming up. And big enterprises like banks, especially new age software companies like Google, Facebook, they need data scientists like anything, because they deal with data. The fundamental source of revenue for Google, Facebook is data. Your data, my data. So they obviously need data science. And same thing with banks. They have a lot of data. They need to extract information from it. Insurance companies, BFSI, any BFSI, banking, finance, and insurance companies. They all need data science. Okay. So I'm already an experienced IT pro. Is there any advantage in switching careers now? For example, you are doing web programming, or you're doing Android development. Now, is there any advantage in shifting careers now? Yes, there is some level of advantage. The advantage being, you're entering a hot job market. Okay. And next thing is, there is going to be some level of competition for you, and that's going to be there in any subject, any area. But this is one area where, if you understand the concepts well, there is a lot of shortage of jobs. If you understand everything well, if you fulfill their requirements, I'm not saying there is jobs for everybody, but if you fulfill the requirements well, there is a lot of potential, and the amount of salaries is way higher compared to, say, web programming or other enterprise programming. Okay, so the advantage on switching careers, if you're able to do it efficiently, you don't have to leave your job, stay put in your job, learn this thing, and then you can slowly get on to a career in data science. Okay, the transition typically takes 6 months. So don't opt, or don't be optimistic to change your job in less than 6 months. If you can, well and good. You'll be a hero. But typically, what I've observed is, it will take at least 6 months, because there is you will be doing your job, or even if you're a student, you'll have your own things to do. So to understand data science, to understand all the algorithms, to learn Python, and then to do some of the projects and all that, it will take some time. Okay, so make sure that you give yourself a good 6 months. And if you're in a job, make sure that you spend at least 3 to 4 hours a day. Okay, if you don't do that, then it's difficult. At least 3 to 4 hours a day, minimum 3. Okay, every day we learn some things, you have to go practice it. If you don't do that, it will be very difficult. Next, I have a non-technical background, MBA. Will this course help me? Some people, for BTech, this course is pretty much suitable. You don't need a PhD. Some people will ask for a PhD. You don't need a PhD. Definitely not required. Okay. Even if you are from a non-technical background, not a problem at all. Because there are requirements for technical as well as non-technical people. There is no need for a BTech, because like I said, it's not programming heavy. You don't need heavy programming. Okay, it's concept heavy. Machine learning, deep learning is all concept heavy. Even the biggest program, once you have all the data, in fact, most of the time you'll be working on massaging data, getting the data, manipulating data. The entire data pipeline is very tedious, cumbersome, and time-taking. But the actual data science or machine learning algorithms will not be more than 1,000, 2,000 lines. In fact, 2,000 lines can produce a huge project, Okay, so like I said, data science is not coding heavy, it's logic heavy. If you are not comfortable with logic, then this course is not for you, or data science is not for you. Okay. I'm a fresher, just passed out this year. Will this course help me? Yes, freshers, like I said, give yourself 6 months, and there are jobs for freshers as well. You can easily get into some kind of companies because there is a lot of hiring going on. Okay. What is the price of the course? Price of the course is 35,000. Okay, you can pay it in 2 installments. For the first 20 days, you can just pay the 1 installment, half of it, and then after that, you can pay the remaining amount. Okay, the next thing is what kind of job assistance is provided. Now, there is a dedicated placement cell, meaning once the course is complete, we will make sure that your resume is good enough that the market can notice it. We'll put some projects and then what to talk in that projects. And then we'll push your resume out there and make sure that you get a job. Now, I'm not guaranteeing a job. That's why I'm saying job assistance, because everybody is different. Nobody can guarantee a job, but we will do our best to make sure that you get a job. Okay, especially if you have some kind of experience in any technology, anything, it will be more helpful because you can put up some experience. Otherwise also, that's fine. There are some beginner entry level jobs also. So sometimes you might not even get a job. Sometimes you might get an internship, okay, which will pay a reasonable amount. But once they like you, they'll pull you into the company. They'll say internship with job offer, right? We'll apply for those kinds of jobs also. Either way, if you work hard enough, within 6 months, there is a very good chance that you can land into a job. All right, so that's what I intend to cover today as part of the demo session. And from whenever we start, potentially tomorrow, we'll start with Python, and then as the day progresses, we'll see through all these different topics. Okay. Now, do you have any questions? Sorry. I know that has been long, so 1 hour, 15 minutes. We'll stop it here. You have my email, right? So you can call me if you have any questions on my phone number or on my email, and we'll take it from there. All right, take care, guys. We'll be reaching out to you in case you have questions about the course or the course fee or any other questions, and we'll be able to answer any of your questions. Okay, all right, take care.